Kia ora, welcome to the Lalanga Toolbox. What is matter? Matter is anything that has weight and takes up space. Everything you can see and touch is made up of matter. Here are some examples of matter, like the food that we eat, things we love to play with, things we use at school, the air that we breathe. Everything around us is made up of matter. There are three main states of matter: solids, liquids, and gases. Solids are rigid and keep their shape. They do not flow like liquids. Liquids change their shape and flow. If we put them in a container, they will take the same shape as the container. Gases can spread out and change their shape. Sometimes we cannot see gases. This is matter, 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 this is matter. If we took a very powerful microscope and looked at matter, we would see that all matter is made up of tiny little particles called atoms. Atoms are the building blocks of matter. Scientists have found out that the difference between a solid, liquid, and a gas is that the atoms in a solid are tightly packed and don't move. That's why you couldn't walk through a wall. The atoms are too tightly packed, so you can't move past them. The atoms in liquids are still connected to each other, but not as tightly as in solids. The atoms can slide past each other. That's why you can swim in water, because the atoms are free to slide past when you move. And the atoms in gas are not held together at all, so they can move about freely. That's why you can drive or move through fog. The atoms are moving about far more freely than in water, so we can move through fog or air without much effort at all. A long time ago, a famous New Zealand scientist called Sir Ernest Rutherford was the first to discover what an inside of an atom looked like, or what an atom was made of. You may recognise Sir Ernest Rutherford from the New Zealand $100 bill. Sir Ernest found out that all atoms have three parts. This middle bit, called the nucleus, which is made up of protons and neutrons, and around the outside a cloud of electrons. This is important information because the universe is full of all sorts of different atoms, each with a different number of these protons, neutrons, and electrons. Each different atom is called an element. Some of them have names that you've probably heard before. But let's recap all that. All matter is made from atoms. Atoms are the building blocks of matter. And inside matter there are different kinds of atoms, and we call them elements. Feeling confused? Well, I'll explain it more here. Do you like chocolate cake? Well, if you've ever made a chocolate cake, you'd know that a chocolate cake is made up of many different ingredients like cocoa, sugar, milk, butter, baking soda, icing sugar, and flour. Think of the different elements as the different ingredients in the cake. Like the ingredients, every element is different and adds something special to the cake. Chocolate cake is like matter, made up of different elements like cocoa and sugar, butter and milk. Or what about Lego? You like playing with Lego, right? Look at this Lego creation. Notice how the whole creation is made out of lots of smaller pieces? These small individual pieces are the atoms. But notice how there are different kinds of pieces. Each different kind is a different element. This Lego piece is a 2x1 yellow Lego element. This is a 3x4 blue Lego element. Why is it important for us to know about all these different atoms when we can't even see them? Well, because everything in the world, whether it's a solid, liquid, or gas, are made up of the atoms of different elements. And we can learn some pretty neat stuff about what the world is made of by understanding the elements. A helpful tool is a big list that we call the periodic table. The periodic table is a list of all the possible ingredients in the world that everything in the entire universe is made out of. Yes, even you. You're made out of these ingredients as well. For example, water is made up of two different elements, hydrogen and oxygen. Or table salt is made up of sodium and chlorine. Every single solid, liquid, or gas in the world is made up of different combinations of elements from the periodic table. But we want to teach you something that will make you the smart kid in the school. Look closer at the table. Notice anything? Every element has a special code and some numbers next to it. We're going to teach you how to read these extra pieces of information about each element. Let's take hydrogen for example. This number here is what we call the atomic number. The periodic table starts with the smallest atomic number, here, and works its way up. It starts at element number 1, hydrogen, and ends at element number 118, organethane. So we can use the atomic number to understand where this element is on the table. The atomic number also tells us how many electrons and protons the atom has. This word here tells us the name of the element, and the letters here tell us the symbol or the code for the writing the element without having to use its whole name. And this number here tells us what the element's atomic weight is. Atoms are so tiny that we can't weigh them on scales that measure grams. Instead, atomic weight is measured in a special unit called daltons. Let's try to read this one. The name of this element is hydrogen. The symbol of this element is a capital H. The atomic number of this element is 1. How many electrons and protons does each atom of this element have? 1. And this number tells us that this element, hydrogen, weighs 1.008 daltons. Let's try it again with this element. Element number 26 is called iron. Its symbol is capital F with a little e. That's a bit weird. The reason iron uses Fe is because we have known about iron for centuries. Years ago, the Latin name for iron was ferrum. That's where the Fe comes from. We expect iron atoms to have 26 electrons and protons, and the weight of one iron atom is 55.85 daltons. So, there you go everyone. You have just learned way more than the normal child about states of matter. In the next lesson, we will learn more about solids and what makes a solid so special. See you next time.